Maybe with a little practice, I could tell myself to relax it. We'll be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, we're falling off, the fight's too hard. Wake up, my love, please don't give up on me. It's hard. Wake up.
What is up, you guys? We are here at it again for another epic day of 100 Days of Rootkit. Are you guys excited or what? Let's do this thing. I see you guys are going crazy in the chat. I see Leo doesn't understand jokes. It's alright. We're used to it. He doesn't have a good sense of humor. Let's get at this, you guys. Let's go. Let's get some of that lo-fi first. We need some of that chill music to relax our brains from exploding the last couple days. But we're towards the end there. Now, before we move forward, you know what time it is. It's time to plug all of the amazing things Rootkit has to offer, alright? We've done this how many times already? We're going to do it a lot of times more, alright? First, money. Don't have it? Here you go. Go onto our site, click on blog. You'll see something there called Week 1 Giveaway. We also have links to it in the description. Go fill out your entries and get your stuff. We will be drawing the winner tomorrow on stream, alright? And then, guess what? We're going to do it again. Why? Because we have no concept of money, alright? We just lose it all. We give it all away. We're kind of stupid, but it's alright. Hopefully it works out eventually, or, you know, we'll see. But after that, if you do have money, hey, right here, donate to the stream. No bits, no subscriptions, none of that weirdness. Just a donation straight here. Claim yourself some merch. Helps out a lot. That's the whole point of the streams. And guess what? There are big goal markers we are going to be hitting as this fills up. Includes shaving my head. Includes shaving this beautiful beard. And you know, our number one goal during the stream is 100% not to hit the 20k mark, because I do not want to shave this beard. This beard is what gives me my manly pride, alright? If it is gone, then I have nothing left in this world. Nothing. Not even, well, I guess I got my kids, but really, kids over the beard? Like, okay, we'll move on. Alright, let's see here. So, awesome. You guys are awesome. Make sure you fill out those things. Last couple hours here for the week 1, and the giveaways are gonna be getting pretty crazy, especially because I just got my email confirmation that our sweaters are on their way, and those are gonna be pretty cool. Alright, sweet. Any questions from the last lesson? Alright, go ahead and put your questions into the chat if you have any from the last lesson. Now, how today's gonna work out, we're gonna finish up talking about all of the numbers, binary. We're in the matrix deep, alright? Once we finish that up, we'll be done for today. Tomorrow is gonna be pretty much a review day. Any questions you guys have, anything that you want me to go over, we're gonna go over it. We might go over some questions. We won't be teaching anything new tomorrow. It's just purely review. Hopefully it's a shorter day than normal, we'll see. And then after that, Taylor's going to be taking over for a week. Taylor's going to be talking, chatting, and hyping you guys up for the next week for computers internals. And I'm kind of sad because I kind of want to teach that one, because internals are pretty awesome. All right. So let's see here. What do the sweaters look like? Well, maybe I can give you guys a peek if you guys really want. Let me see if I can pull them up. Come on, where's my email at? Here we go. Can I bring this into, alright. Really small picture, but there's the front. It has, can't really see, it's pretty blurry, but it's this nice cool little sticker guy right here. Alright, if that will get into 100 Days of Rootkit right at the bottom. And even better, the back of it says Rootkit. Alright, super simplistic, but super elegant, super awesome. Alright, super heavy duty, meant for those cold winters, because it has been some cold winters. Alright, especially if you live up in New York. All right, really, really cold winters this year. Let's see here. Any other questions before we move forward with our epic journey down computer science lane? Nothing? Go on and drop them in if you do. And let us get on to it. So last time we left off, we finished with all the fun little conversions of how to convert numbers to hex, decimal, hex, binary, and octal. It was pretty simplistic, nothing crazy, just it's kind of manual, you know, but nothing too intense. You could teach it to a second grader, all right? Why it's locked behind paywalls in colleges? To make money, that's what it is, all right? There's nothing else beside it. Now, if I can remember why I brought this up, it was for the calculator. So by default, if you're using Windows, by the way, Epic shirt. If you donate, you can get one of these Epic shirts. They're super awesome. Yes, the answer is yes to your question. This is the same shirt I've been wearing and I have not washed it. All right? No, I have not. And I'm not going to until tomorrow. All right? After we wear it for the next stream. Then I will wash it. All right? It's up to you on figuring out whether I've been wearing it all day, every day, all week long, or just during the streams. All right? You guys can debate that in the chat. But in your calculator here, by default, it will look like a normal calculator. Nothing fancy. Up here, you'll see it says something called scientific. All right? That's what it is by default. But if you open up the little sidebar here, you'll get a couple extra guys. Something there is called programmer, which is what you guys are now. You guys are all programmers. And if you click on that guy, you'll be able to mash in numbers here, like the number 50 or 500, and it will immediately tell you what the hex version, decimal version, octal version, and binary version of that number is. So, just a little neat thing in here that may be valuable to you guys. Maybe it's not. Don't worry about these. You'll learn what bit shifting is here soon. But these ones should look very, very familiar to you. We have talked about them before. By before, I mean for a couple of days now. So we're going to go back to standard because we're going to be in the standard realm. Let's see. Thought you said you were going... You were going to say you wasn't going to wash it till the 100 days were over. You know, if we hit 1,000, all right, by tomorrow, I won't wash it till 100 days are over. If we don't hit 1,000, then I am going to wash it, all right? It's one stinky shirt, that's right. I'm a stinky, stinky boy, but it's all right. I'm in an enclosed room. No one else is around me. Perfect programmer setup. You don't bathe. Don't brush your teeth, all right? All the stereotypes. We got them nailed. Not really, but all right. So let's get to it. Converting. Where is it? There we go. Yep, this one. Convert using grouping. All right. Let's move forward with this. This is going to be a little easier than what we went over before, I promise you, because now we're not dealing with normal numbers. You know, everything except for base 10 is in that 2 times realm. So binary is 2, base 2. Then we have octal, which is base 8. And then hex is base 16. In the 2 realms, as in like, we can go from 1 to 2 to 4 to 8 to 16. It's in that multiplication level up system there. That's basically what binary goes off of. And when you're following bases along that line, it's super, super easy to convert numbers between them manually. And you guys are going to see that here. So let's pull up good old Paint so I can show you guys my awesome drawing skills, because I know you guys are loving it. I should probably just quit this and start making NFT art. All right. Shout out into the chat if you guys think that Rootkit should start making NFT art and start posting it. All right, let's see here. There we go. So From bases that are powers of 2, use grouping and expanding. All right, key thing, grouping and expanding. It's super easy if you use this to convert between. For example, it takes 3 binary digits to hold the same value as 1 octal. Octal digit, my bad. And it takes 4 binary digits to hold the same value as 1 hex digit, because they're directly correlated to each other. Also, to what Kawaii said, maybe, all right, Rootkit is opening a Coinbase account. It's almost done. So maybe. We're opening it for research into Web3 stuff, because no matter whether you love it or hate it, you gotta still explore it. As a dev, you still gotta know. So we'll be exploring that realm. Maybe. We'll see. For the 3 of you that would be interested in it, alright? Not very many people out there are interested in it right now. But grouping. Basically, 3 binary digits equal 1 octal digits, and 4 equal a hex digit. Alright? Converting from binary to any base that is a multiple of 2 is super easy. So let's go ahead and convert this guy right here into octal. And you can see that all we do is we convert it into pairs of 3. And then we add up those numbers and we'll get the octal value. So let's go ahead and grab our brush here. And let's go and write this 1 0 1 1 0 0 1 1. And we have now entered the matrix. But we can go ahead and take our number and literally just draw lines after every 3 of them, and we got our answer. It was that easy to convert to octal. So all we do now is we add this number together. So this is in pairs of 3. So we're only adding these 3 and these 3 and these 3 together, not the whole thing. All right. So we got 1 and we got 2. So we got 0, 2, and 1. So we got to add all those together. And that gives us 3. And is the stream still live? Because I think my monitor just, holy crap. I wish you guys could see this. My monitor just died, I think. Hold on. Oh no, my computer's going wacky. Did that fix it? Okay, I thought my computer was going to crash for a second. Okay, 3 for our first number. Next, we got 0 in the 1's place. We got 1 in the 2's place. And we got 1 in the 4's place. So that's going to be 420. Blaze it, motherfuckers. Well, maybe I shouldn't say that on stream. That's a little too violent. Okay. So 6. All right, 6 right here. And then we got this guy, all right? 0. So 0, 1, 2. And then you'll see we're missing our third number. Third number might as well not be there. It's not there, so it might as well just be 0, right? So 2. And that's how we convert to octal. Super easy, you guys. It's just grouping and then adding up those numbers together. Any questions in regards to that one? I don't see any questions right now. If you guys have any questions, go and drop them in the stream. And we're going to move on. Let me just double check the stream is still going on, because now I'm scared because my computer was doing some weirdness. Let's see here. Yep, stream is still going on right now. Perfect. I didn't break everything. Alright, so let's see here. Hex. Alright, next evolution. This might break your mind. Alright, so stick with me. Let's go and write this one out. 1 0 0 1 0 1 0 1 0. I feel like I'm in like that SpongeBob episode or that Futurama episode where Bender is just like sitting there just saying all the numbers real quick, and what are they, time traveling or something? I can't remember. So this one, throw you for a loop. When you're going to hex, it's 4 this time. Bam. Whoops, I should probably change the color here. Bam. Bam. Wait, oh no, that's not the 4th one. Woof. There we go. And we're pretty much done. We just add up the numbers and now we have our hex value. Super, super easy when you're going to binary to these other guys. So let's go ahead and right here, we have 0 in the 1's place, 1 in the 2's place, 0 in the 4's place, and 1 in the 8's place. So this is going to be 10. And 10, again, fingers, we have 9. 10 is going to be A. We're going to start with A, because we start entering alphabet realm there. Here, it's all zeros across except for this one. We know this is going to be 0, and this is the 1's place, and this is in the 2's place. Alright, so we can write our 2 here. And again, even though we only have 1 here, that's just fine. We don't, the rest are just going to be zeros, but we don't need those zeros there. Alright, 1 is going to be in the 1's place, which means it's going to be 1, which means this is our final number. Super easy, alright? Nothing too complex here. Any questions on that? Let's see, let's check the chat. Every coin and signing up gives you a root coin kit, which includes some bonus stuff. I was about to ask why they weren't even. Nope, I've always wondered why is this important to know? Important to know in regards to, I'm just saying that now, important to know like the conversion stuff, or important to know on the crypto stuff, because other people are still talking about the crypto stuff. I was about to ask why they weren't even. I like having 4. So you like converting to hex. Yep, it's nice and even. For those of you guys that really care about whether it's even or not compared to the odd one. Converting. I've always wondered why this is important to know. Yeah, converting is important to know because depending, this is not, I'm going to just be straight up honest. This is a computer science cert, and it's very general, hitting on a lot of key concepts, because this may be important to you on the job that you do and may not, but it is important enough we got to talk about because it is core computer science topics. Most of you guys, this will probably never be too relevant in your career, but some of those that want to do more low-level stuff, maybe stuff with NVIDIA, machine learning, kernel development, OS development, making drones, I don't know, something that requires you to be programming closer to hardware level things, this will be important because the closer you are to hardware likes talking in 1s and 0s, which means you may have to do conversion of this stuff on the fly, and you may need to understand what's going on here behind the scenes. Alright? For some of you, it is good to know just in case. The thing is, for the computer science realm, it's good to know as much as possible, because everything is always going to be relevant to each other. You just don't know when it will be relevant for you, but it will be relevant. Alright? So always be open to looking at everything that's around you, because you just never know. Like, I don't know, OpenAI stuff. They've been producing their GPT-3 models for a while. ChatGPT is their new viral sensation. It's good to know about those things, because if you don't, you won't be able to make potentially as compelling products, because now if you do know about it, there may be something you're working on that might greatly beneficially benefit from it, and you may want to integrate it in whatever you're doing. Something like this, there may be a use case where you're like, oh, I may not remember exactly how to do it, but I know we can do it. It's really simple and it would benefit us. That's the big thing, is just having those kind of bookmarks or check marks in your mind that, I kind of know there's this thing that exists, and with what we're doing here that exists, we can kind of mesh them together and make something even more powerful. Hence why we're going down the Web3 rabbit hole. It's crypto winter. Things are cheap for engineers to get into, and we can now mess around with stuff, because you just don't know if it's actually going to be something relevant or something that we need or not. Or maybe just completely waste of time. But you should never blow off anything. You should always look at things a little bit more in depth. Let's see here. Can you give me an example, please? It might help me understand. Yeah. Style transfer is a generic idea, applies to images. Let me look up style transfer for... Okay. That is a way for machine learning. I'm going to give a slightly different example, but style transfer is basically a machine learning technique you can do where you basically train a model and that will mimic a style of your favorite artist. And then you can put in a base image and then the style that you want it to go to, and bam, you'll get a stylized image of it. More of an example I was going to give is, let's say you're developing on a Arduino. I got some hardware in here. How many guys like playing games? All right, we'll give an example here too. This is probably the best gaming service in the world, Google Stadia. Totally still around today, right? All right. Give me 1 second while I grab through these drawers full of random weird stuff. We'll do this guy. And here we go. Good old Raspberry Pi, right? So let's talk about some of these items here. All right. You want to dev for Xbox, Sony. Maybe you're starting your own game studio. All right. And you need to make hardware. Or maybe you're doing more of the hardware engineering side and you're close to the actual hardware. Or you're a hobbyist and you're messing with Raspberry Pis or Arduinos. Or you're doing something with Bluetooth. This is a little Bluetooth device that just spams into the airwaves a bunch of junk. This is where information like this and knowledge of this might be important. Why? These guys, they don't have a lot of storage, all right? But even if you do get a lot of storage, like if you buy like a terabyte or not SSD, the card here, memory card, SD card. God, I don't know why I was blanking on that. It doesn't quite matter because at the end of the day, your hardware is really, really limited. Additionally, you have these pins right here that you can connect hardware to, like light bulbs, I don't know, literally anything you pretty much would want to these guys directly. And these guys are going to be talking in ones and zeros at a very, very low level. The important thing, especially if you're communicating over the wireless, whether it's Bluetooth or radio frequencies or whatever, you're really limited on your bandwidth. People, constantly think that bandwidth's really easy to come across, especially if you're using Wi-Fi. Sure, in normal like USA, but a lot of rates, especially for controllers and stuff, are not that high. So you need to really compress the data a lot. So how do you do that? Well, by using toggle switches essentially. So instead of you broadcasting a lot of information of maybe how the state of the entire controller is, taking up a lot of data, maybe a lot of integers, a lot of XYZ, you want to compress it as much as possible so you can make that super fast sub 1 millisecond controller or keyboard. All right, how would you do that? How can you compress the data that you need to send in a small amount as possible? Well, that's if you're using straight up binary and using potentially flags. So let's say the controllers here. Let's say the what do you call these? The joysticks. The joysticks. You want to send over the value of the joystick we're not going to deal with 3D. We're just going to deal with a lower level just to get the concept across. But in the least amount of data so you can have the most responsiveness possible. Well, you can use groupings like this to help you out. So let's say you want to use something like octal because you just need at most 8, or let's just do hex, 16 like power values. So you're either like a little bit up, more up, more up, more up, or max. And let's say that's a range of 16, or better yet, the range of 16 is from all the way down to all the way up. All right, you could allocate, you could use by default just a normal variable. All right, a normal variable in, like, let's say we were in Python. Let's go right here. So by default, if you don't know programming or Python, don't worry about it. It's not about you knowing, it's just about the concept. But let's say controller joystick equals, let's say the power level is currently at 5. I just made a variable. The thing is, this is a big variable. This is potentially 8 to 16 bytes large. And if I'm sending stuff over wireless, that's potentially a lot of data. Instead, I can break it up because I only need 16 at most. And 16 is only going to be up to 4 bits or 1 nibble information. Also, I have another second joystick. So let's say I want to track this one also. It needs 4 bits or 1 nibble of information. What do we have right now? We have 1 byte. So we could be smart instead and just do 1 byte of data sent over the wireless to track the up and down of both of these guys, all right, at once, instead of doing potentially twice as much data or more. And how you can track the value easily, you can either, one, in your program, literally assign the bit values, but that's kind of low level and annoying. What would be easier is if we just assign maybe a hex value to the first part and said, oh, they're at power level 5, and the second part is at power level 10. And we just send that over the wire. So it's just different ways of displaying and compressing the data to be potentially like smarter cost savings. Again, this isn't for a lot of applications that most normal devs will do, but this is something that's vitally important. I mean, people that build the backbones of the internet, to make it faster, you need to be more efficient of what you do. And so this is a way they'll do it. Same thing if you're communicating on a Raspberry Pi that has not very fast of a processor. Again, I told you guys yesterday a little sneak peek of processors. Used to be 8-bit, which means they would only process 8 bits of information at a time. Then they went to 16, 32-bit, and now we're at 64 bits. So to be as maximally efficient as possible for 64-bit systems, ideally, if you can keep it at 64 bits or below, you're being as optimal as possible for your operations. Same thing with these. I don't know what the bit rating for these are. I wouldn't imagine they might be 32-bit, but that is something that you might want to keep in mind, because if it's a 32-bit system and you're passing 64-bit variables, which you can do, it will slow things out immensely. And same thing with wireless. Wireless does this all the time automatically without you knowing, and Bluetooth systems. Any questions on that? Does that make a little bit more sense? I see a question for the CERT exams. Are there time limits? Yes, there are time limits for the practical and for the written test. And by written, I mean it's not actually like writing. It's multiple choice stuff. Awesome. Yeah, no, that was a really good question. And as you guys go through computer internals and we move forward more and more, you'll start to understand these base concepts and how they relate to stuff moving forward. But The big misnomer for a lot of new devs is that you can be very like gluttonous with the data that you use, but you can't always. It's the bandwidths on everything is not infinite. They're really large now, but they're not infinite. So you gotta be mindful of it sometimes. All right. So let's go ahead and do another conversion here. This time we're gonna do the reverse. So we did binary to octal and hex, and now we're going to do octal and hex to binary and show how really simple and easy it is. So we have this number 452, and this needs to be converted into binary. I see question, can you retake the exams and at what frequency? Yes, you can take the exams. You can retake them as many times as you want, and right now we're doing a 3-month waiting period between your next exam. That may change to 6 months later on, but right now it's 3 months. So the 3 months is a cool down period for you to take time to learn everything you need. But also, we're not going to just let you come month after month and retake and retake and retake and memorize the test. Let's see here. We will do light review after you take your exam. You won't be left in the dust. We're not going to tell you exactly what you missed and what went wrong, but we will review with you lightly on what topics you need to like cover up on. You will not be just screwed over, right? So let's do this conversion here. So we know when we're going from binary to octal, it was 3-digit segments or 3-bit segments going up to one number. So we just do the reverse. Every number here is going to turn into 3 binary bits, 3 bits. So this 2, all right. We know the first 1 and 0 we do is for the ones place. So 2, not going to go in there because we can just put it in the 2's place. And then we can finish up with the 0 here. So we got our 3. So 5. Sometimes it might be best for you to go in reverse order. So I know we might be tempted to do what I just did there from smallest to largest, but sometimes it might be best to go largest to smallest so you don't miss something. So the largest is going to be a 4. So 4 can go into 5. So we'll go ahead and do a 4. And now we have 1 left over. So 1 can't go into 2, but 1 can go into 1. So there we go. And then 4. All right. And the first number, the largest number is a 4. And then we can just do 2 zeros here. And bam, we've done our conversion. And if we look here, we got the exact same number. And that's how you convert. It's pretty, simple. Just break it up into 3 segments when you're doing an octal. And now let's do it in hex, and it's going to be 4 segments now. Largest to smallest, lowest works best for me. I agree. That is how I should have done it the first time. That is the better way to do it. Let me see if there's anything else in the chat. All right. We got a 2, not a 5, D, and 5. Awesome. So let's convert, and this time we can even write over here a little guide. We have the ones place, 2, 4, and 8. So now we have our little guide right here that we can look at while we're going through this. So 2. We know 2 matches up with 2 perfectly. So 2 can convert to 0, 0, 1, 0. Perfect. So we got the first little bit. Let's do D. Now, what number is D? Let's bring out the handy tools. 9, 10, which is going to be an A, B, C, D. 13. So let's go ahead and write 13 right here. All right. So we can do 8 into 13. All right, what's 8 minus 13? That's going to be 5. So 4 can go into 5. So we'll go 1 here. And we got 1 left over. 2 can't do that. And then we got a 1 right here. And then we have 5. 8 is too large. 4 is perfect, so we'll subtract 4. 2 is too large because we only have 1 left over, so we'll do 1 there. And we've now successfully converted this. I don't know why there's a stray 1 on the answer here because it's correct right here. Ignore the book. Another revision that needs to be done. But this is our correct answer. Any questions on that? Is the low vibes music too low and too vibey? I think it might be a little too low. Let's turn it up a little bit. There we go. All right, no other questions. So we shall move on. So we went over conversion of normal numbers, aka base 10, to binary, hex, and octal. All right? It was super easy, just a lot of subtraction, division, and the remainder stuff. All right? Okay, now that might be a little too loud. At least for me. There we go. Then we went over the same thing on, but reverse. And that was super easy. Going from binary to everything else is super, super easy. Right? As long as it's the power of 2 item. So octal and hex. So let's move on here. And let's talk about unsigned integers. Alright, if you guys remember that from before, those were... Let's hear it in the chat. Where can I find the link for the giveaway? Good question. The weekly giveaways, if you go to rootkit.org, remember we're a nonprofit organization. We are not rootkit.com. Rootkit.com is by another company that we work with, but we are not rootkit.com. Rootkit.org. Go to our blog, and that's where you'll find our giveaways. And we'll be posting every week here. So you can go and click on that and enter the giveaway. Also, I believe there should be... There's not. I'll have to fix the descriptions, but there should be the links in the descriptions. Alright, so unsigned integers. We talked about this a little bit earlier, so just to refresh, they are whole numbers who have no negative values, aka they're all absolute values, or they're always positive values. Alright? They're happy people, they're always positive. You know, those people you got around you that maybe you don't, maybe you just have negative friends, but you know, those people that are always smiling and stuff, and you're sitting there, you have 2 reactions. You're either 1, how do I get some of that joy? Or 2, God, you're so annoying, get out of here. So, always positive, alright? Unsigned, they're missing the minus sign in them. They have no sign in front. Word size depends on the computer, aka word size, again, words were 16 bits, and this does depend on the computer architecture. We're going to be going with 16 bits because that's the most common, but again, this is Wild Wild West. Data is however you want to interpret it, and one way that Microsoft might want to interpret something is different than Apple, different than how ARM might want to process it, or I don't know, you're building an operating system and you want to just have it cursed. You could interpret it some way different. It's totally up to whoever is making the thing and stuff. So let's look below, and we have some examples of integers, and we'll get to that here in a second. But these are going to be going over the max value of unsigned integers, and some of these numbers may look really, really familiar. All right, again, a byte, which is 8 bits, can store up to 255. All right, it's going to be 2 to the power of 8 minus 1, because remember, 0 is included. All right, 0 is one of the total numbers. And you'll see 255 used a lot in things like settings, maybe the color combination or color value that you're allowed to use. It's going to be used very commonly, and this is the reason why. There is a reason behind the madness. I didn't just pull it randomly out of a hat, all right? There's also words, which are going to be 16 bits in size, all right? And that can hold 2 to the 16th, which is 65535s, all right? This might look familiar to you guys that have ran Minecraft servers or joined a friend's game or something, because this is the port number they run on. Why? Because ports only go up to this value, because ports behind the scene in internet land, when you're dealing with anything that's networking, they're 16 bits in size, all right? And they can only have a max value of this, all right? Now, we have double words, which hold up to this value. There's a very infamous event that happened in regards to this. This is 2 to the 32. You can hold 32 bits. Does anyone know an infamous event in current history where this ended up being an issue and had to be fixed? Anyone at all? Any guesses? There might be multiple. I have one in the particularly on the top of my head. So, how many of you guys have watched YouTube before? YouTube? Anyone? It's a small indie site by a small indie game company, right? Anyone? YouTube? I know you guys have watched YouTube. Get out of here. Alright? YouTube. YouTube has databases. In a database, you have to state how large your values are going to be. So they said, view counter. This is back when they first made YouTube, back in, I don't know, early 2000s. Was it 06, 05, something like that. They said, let's do a double word. Are we really ever going to hit that many, that large of a number for view counter? Like, that's a lot of people. Like, who the hell would sit here and, like, we'll have bigger problems when we get to that. So YouTube was using a double word sized integer, unsigned integer, for their view counter for a very, very, very long time, until probably, I don't know, was it like a decade ago? It was very recently where, God, was it the Psy video? The Open Gangnam Style? I can't remember which video it was, but it was the first video to break 4,294,000,000, etc., views. And you know what happened? It rolled over. We're going to go over rollovers here soon, but basically it broke the view counter because they couldn't handle data of a larger size. So YouTube had to go back to the drawing board and change all of their data. And you know what they changed it to? I don't know this for sure, but I'm 99% confident that they upped the value. So now everything is going to be probably a quad word, so 64 bits in size. So they can, now the view counter can go up to this size. I'm not 100% confident on that one because I don't know if they reveal that type of information, but pretty confident that they at least went to 48 bits, if not 64. 64 is probably more likely. So now their view counter doesn't break, and you can go well beyond 4 billion views. All right, you guys learned some more. What's YouTube? Get out of here. Learn some more history there. Yeah, look it up. It's a thing. You can look up the article. So again, this is just a review of what we went over here. The bits that you can have, the minimum value and the max value for all of these. All right. I don't know why these ones are slightly different. Maybe I just got lazy and didn't want to type it out. But, all right, so let's talk about addition and how you do addition in math. Addition with binary, right? When adding unsigned binary values together, you will come across cases where you will need to carry over a number. This works the same way it does in normal decimal math. Below, the table on the left shows some values that have carries. On the left, an example of binary and decimal addition utilizing the carry. All right, this is not on the left because we got it shrinked up right now. But you can see we're adding 15 and 16 right here in decimal. When we add 5 and 6 together, we get 11. So we'll put 1 right here and carry the 1, and then we get 3. Simple enough. When we're doing it in binary, it's pretty much the same concept. So we got 0 and 0, that's going to be 0. 1 and 1 is 2. Remember, 2 in binary is a 1 and 0, which means we're going to put a 0 here and we're going to carry the 1. Alright? The 1's going to be carried, and the formatting looks weird on the book. I know, I'm sorry. It's because I just how it all renders. But it's right here. So we have 1 plus 0 plus 0. So we get 1. And then 1 right here. So we get a 1 right here. And we get our answer. Nothing fancy. Nothing crazy. How I like to think of it, you're only going to have 1 or 0, 1, 2s, or 3s when you're doing math. So if thinking about the binary version of these, like 1 0 or 1 1, is confusing to you, I mean, I think this is the easiest way for knowing what you carry and what you put below. Then just remember 2 0 is going to be nothing goes down below, because you're kind of like going 0 1 0 and then 1 on what you put below, and then these guys are what you carry over. Just some alternative ways of thinking about it if it's not super clear for you right now. So here's another example of binary addition with some carries. So we're gonna go ahead and copy this over. This is gonna be 1 0 1 1 0 1 0. And it's gonna be 0 0 1 1 0 1 0. Alright, let's scroll away from there. Check if there's any questions. Nope. Alright, let's go and look at this. So let's add 0 0 0 1 1. That's going to be 2. 2 means we're putting a 0 right here and carrying 1. 1 0 0 going to be 1. 1 1. That means we're going to put a 0 right here and carry. Bam. Now we have a 3. This is the highest that you'll ever have when you're doing binary. And 3 means we're going to have a 1 here and we're going to carry 1. Alright, and then we got a 1 here and a 1 here. And that is our answer. And if we look, bam, we got it. Any questions there on addition? Thanks for the follow, Matthew Flavella. There we go. I said it perfectly, alright? Alright, any questions there for the addition? I mean, it's not too difficult. The most confusing part, at least for me, was just when you actually put a 1 at the bottom and when you put a 0 when you do have a carry. Alright? Again, remember, you'll only ever have 2 or 3 here. And 2 is always put a 0 at the bottom. 3 is always put a 1 at the bottom, because you gotta kind of think of it in binary. This is a 2 in binary and this is a 3. If there's no other questions, we're going to move forward to subtraction. I do want to, hold on, really quick fix this. I fixed this on the other scene, but it didn't convert over here, and I was like, that doesn't make any sense. Hold on, where is it? There we go. So that way you guys are encouraged a little bit more here. Sorry, this is like a side thing, but it's gonna irritate me if it still stays the same. I might forget it later. Here we go. We don't want session. Is this what we want? There we go. Top donor. And we can keep follower. I don't want no sub stuff. Let's go to, there we go, all top. Alright, there we go. Got some names on the screen. Do some more encouraging. Maybe there's a last donated sample thing there somewhere. I don't know. I'll look later. Alright. So, let's go ahead. And let's get into Inception Land. I told you guys, Matrix, ones and zeros, all over the place. We're deep in the computer. Alright, all we see is codes everywhere. Another thing to just boggle your mind, alright? Did you know computers don't know how to do anything but add? When you subtract, it's actually addition. When you divide, it's actually not just addition but various other things. Nothing is, when you multiply, it's addition and a couple other things, but it's not actually what you do. It's variations of addition. It's impossible to do subtraction. I know, mind is blown. Alright, smarter people than me, alright, figured out how you can do subtraction with addition, alright, and that's how computers do it. Also, why, again, going into a little bit of the things we talked about last time, addition is very, 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 very fast for the CPU to do. I mean, I can't stress enough. It is super fast for a CPU to do addition. There is literally a thing in the CPU. Think of it like as an arm that moves and like performs logic. There's a dedicated thing in the CPU for doing addition. It's literally called an adder, right? It just does addition, and it's one of the fastest things in your CPU. All right, addition is very fast. Everything else you do, subtraction, multiplication, and division, are very, very slow. So if you want to hyper optimize something for some reason, those are the items you should look at to see if you can optimize them. There's lots of other stuff, but let's say you've checked off every other thing you can do and you're left over with just the math. Those items are slow, all right? Most things that you do on the computer, it won't matter, right? You won't be optimizing that much by changing things from division to something else. But just something to keep in mind. So, if they don't know how to perform anything except for addition, then how do we do other mathematical operations like subtraction? By utilizing math magic. Ooh. There is magic in computers, alright? And I'm going to show you guys how to become wizards. Welcome to the world of wizardry, Harry Potter. Alright, to do subtraction in binary, you must complete the following steps to the smaller of the two numbers in the question. Alright? Important thing, because when you're subtracting you have to have at least two items, right? The smaller of them is what you're going to be performing these operations on, right? You're going to get the ones complement, which means invert everything. What does invert everything mean? Switch it around, right? There's only 1 or 0, so you do the opposite. It's opposite day. Add 1, that's called the 2's complement, right? You're doing a lot of complementing because you really got to entice the computer to do what you want here, because it doesn't want to do subtraction. So you got to not just complement it once, you got to complement it twice, okay? Add the number you want to subtract against. If there is a carry on the final bit, ignore it. Then the result is your subtracted number. You guys get that? You guys are ready to do it by yourself? Right? No? Alright, we'll go through it a couple times. Don't worry. I'll walk you guys through it all. You'll learn how to compliment really well, and that way you guys can all get, you know, some nice girlfriends, or boyfriends for the females or males out there watching. Alright. Alright, so we'll go into that after break. So be free. Go use the bathroom or something. Get out of here. All right. We'll see you guys in a couple minutes. Alrighty, we are back. We are back. Sweet, sweet. Doesn't look like anyone had any questions. So I hope you guys are all catching on to this really well. I was thinking, you know what would be really fun? One of you guys should make a little game that's like, I don't know, dungeon crawler or killing off monsters or something, and the only way you can do it is by doing binary math, addition, subtraction, conversion to hex, conversion to octal to binary, conversion to octal to hex, decimal, just weird stuff like that. It would make this a little more interesting, a little bit more fun. If you guys don't do it, then we'll probably add something to Project 26 for doing that, because that seems like fun and an easy way to practice this stuff. Do a couple rewards, things spawn up. Maybe we'll do the whole root crypto coin thing, and you can get coin from doing that and then sell it on the market and make $1 million. At least think you are before we pump and dump it, all right? So we can take all the money for ourselves, all right? All right, Matthew, I'm gonna get your name right this time. Favela. All right, I said it right. Now I've cured the curse. Just have like a traditional, boring American name, like Smith or something. All right. Oh no, just kidding. Yeah, we'll do some rug pulls. All right. Well, since you guys are here with us, we'll include you in the rug pool, all right? And then we'll all do it together. We'll walk away with a couple mil in the bank. All right, sweet. So, let's go over subtraction, shall we? What numbers we got here? We got 50 and we got 45. So, we're going to be subtracting 45 and 50. So 50 is going to be 0, 1, 0, 0, 1, 0, 0, 1, 0. All right, that is our 50. And we're going to have 45. 45 is the smaller of the two numbers, which means we need to do that one last, and we need to do these couple of operations to it. All right, first thing is kind of what we have right here. We need to get our normal 45 in binary, so that's going to be 0, 0, 1, 0, 1, 1, 0, and 1. All right, the first compliment we give the computer is we say, oh, you look nice today. All right, when you do that, you also need to companion it with inversion. All right, so in your head you're saying to the computer, hey, you look nice today, but in reality, in your head, you're like, nah, you look ugly. All right, we're going to be doing the opposite. So we're going to take this number and we're going to flip it. We're going to invert it. All right, so zeros are going to turn into ones, and ones are going to turn into zeros. All right, so let's go ahead and do that all. Bam, we don't need this first number anymore. Now the second thing is the second complement you have to give it. All right, I like your RGB. It's really colorful. All right, second compliment you give it. That will give you +1 bonus points for later that night when you're on the date with your computer, right? And all that is we're just going to add 1 to it. This case, it's really simple because we're just going to add 1 right here at the end. Let me erase this 0 and put a 1 here. But sometimes if you do have a 1 already there, then you're going to have to do math and potentially be carrying over numbers, all right? But we're going to add 1. And bam, that's it. Now we're ready for the subtraction. So if we put it up here, 1, 1, 0, 0, 1, 0, 1, 1. we can now do our the rest of our subtraction. And by subtraction, I mean we're going to be adding these numbers together. So 0 and 1 is going to be what? It's going to be 1. Then 1 and 1 is going to be 0. Carry the 1. And we got a 1 here. This is going to be a 0. This is going to be a 0 with a carried 1. This is going to be a 0 with a carried 1. This is going to be a 0 with the carried 1. And this is going to be a 0 with the carried 1. But if we have a carried 1, we don't carry it anywhere. It just goes away because we're dealing with 1 byte of information here. So anything that can't fit into 1 byte, it gets yeeted all the way across the room. You don't touch it again. And bam, we have our result. Like magic, math magic right here. We have 5. This is in the 1's place. This is the 2's place. This is the 4's place, and onward and onward. We have 1 in the 4's place, and we have 1 in the 1's place, and that equals 5. Any questions there? I know it kind of looked like a magic trick. I swear it wasn't a magic trick. It was just math. That's some math magician. This is why we call them math magicians. That is their preferred technical term. All right. And we use their power to perform magic right here. Any questions on that? No? All right. Then let us continue onward. Remember these steps. This all changes when we have signed numbers, all right? This was too easy. Too easy, all right? Deceivingly easy. We have to make it more complicated, all right? What would the world be if there were things that were just easy, all right? Someone has to always go out about it and make it complicated. So that's what's about to happen. We're going to make it a little more complicated. So let's go and clear the sheet. Signed integers, or referred to normally as just integers. Whenever you refer to an integer or a number in programming, it's assumed that it's normal signed numbers, not unsigned, all right? Are whole numbers with a sign, aka they're going to be positive or negative. Most integer values in programming are signed by default, unless otherwise specified. The most significant bit, what was the most significant bit again? We talked about this last time. I'm gonna wait for someone to answer it. We're not moving forward anymore until someone answers this, all right? I don't care if it's a wrong answer, the right answer, or a meme. We're not moving forward until we get something. Come on. I know one of you guys remember what the most significant bit is, alright? At least give me a guess, alright? Guesses are okay, aka our theme song, Whoopsie, alright? It's okay to make mistakes, that's how you learn in programming. It's required to be a good programmer. You must make a lot of mistakes. You must mess up a lot to be a good programmer. To the left, to the left. I like that. To the left, right? The most significant bit is the most leftmost bit, all right? The one with the highest value, all right? It holds the sign where 0 is positive and 1 is negative, also known as the sign bit. Thus, a byte would only have 7 bits for its integer's magnitude instead of 8. So, when we look here, signed bytes of or signed integers of various sizes will have a smaller total value compared to their unsigned counterparts. So this is another optimization thing that you may want to do when you're programming, if your language allows it. Not all languages like Python really allow this because it will always assume by default. You don't need to micromanage this. But if you do have to manage this, Again, this is an optimization thing. If you know a number that you're going to have, like let's say for example, a view counter is never going to be negative, then you shouldn't be using a signed bit because it's never going to be negative for two reasons. One, safety, because if it's never going to be negative, why even let there be a chance of it being negative because someone's doing something weird? And two, you get more numbers. You get a whole magnitude more. You get a larger top range. For example, this had a max in unsigned land of 255. Now the max value you can have is 127 because you only have 7 of the 8 bits to work with, since one of them is going to be used for your sign. All right, and then here you can see the whole negative to positive value. This again is probably something you'll commonly see when you're doing settings or sensitivity or anything is a top of 127. All right, it becomes because someone's using a signed integer. All right, and these are just all the values that you can have from min to max. Any questions on that? All right, in a byte, there are 8 bits. The signed bit, or the most significant bit, is 0 if it is positive and 1 if it is negative. Here's an example of a negative byte. You can have -0 in binary. That is a legit thing. You can have a +0 and a -0. All right, so be aware of that. That byte is actually the number -128. My bad, I messed that one up. That's 128. I swear in other conversions or interpretations you can have a -0 or a +0 also. But this is going to be 128, the max negative value you can have. As you can see, the signed bit is making is a 1, making it negative. Negative numbers are always in a 2's complement format. Let's explain. The number 20 in a byte is going to be this. All right. If we want -20, we need to get the 2's complement of 20. All right. Remember 2's complement? We can't just complement once. We got to complement 2 to get the negative version. So when we were doing our subtraction here, how did it work? Well, we were actually converting and getting negative versions of everything and then doing addition, because when you add a positive and a negative number together, it's like doing subtraction. So we're doing the same thing here as we are right here for negative stuff. So again, complement 1 is you say complement, but in your head, it's the exact opposite. You're flipping everything over. You're literally flipping every bit to its opposite. Then complement 2, you say something that hopefully will give you a pointer later, aka you're going to add 1 to it. 1's complement, flip, 2's complement, add 1. And that's how you'll get the negative version of that number. So let's go ahead and walk through it. So we got 0, 0, 0, 1, 0, 1, 0, 0. Sweet. This is normal 20. Now we need to give it the first complement, which we're going to reverse everything. So 1, 1, 0, 1, 0, 1, 1, 1. And then second complement. We want that pointer for later. So we're going to add 1. Here we're going to have to do some carries. So 1 and a 1, that's going to be 2. 2 means we put a 0 here and we carry. This is going to be 2. So we put a 0 here and we carry. And we just drop the 1 here and we're good to fill in the rest. And that's our -20. And if for some reason you wanted to flip and go back, all right, we can take the ones complement. So we'll go ahead and do the negative again. So this is our negative 20. Let me write that. And we're going to do the opposite. So the ones complement. So 1, 1, 0, 0, 1, 0, 0, 0. All right. And then we're going to add 1, the 2's complement. So we're basically doing the 2 steps all over again to reverse everything. So we're going to add 1. And that's going to be 0, carry the 1, 0, carry the 1, 1, 0, 1, 0, 0, and 0. And bam, we're back at our original 20. So binary is super awesome because literally you can do the same thing twice and you'll be back at the original. It's true and false, 2 things over and over again. It's pretty much like super awesome. You don't have to learn new formulas. You can just repeat the same thing over again and end up where you started. Any questions to that at all? All right, let's move on. Overflows. All right, this is something to be aware of. This is very important. And this is what I was talking about earlier with the YouTube thing and the view counter. And when it hit the max, it overflowed and some weirdness happened. Well, we're going to talk about overflows and overflow vulnerabilities. And this is an actual legit thing I need you guys to pay attention to because this is actually really, really important. This is how you can be hacked. This is how your game can be pretty much messed up, destroyed. Leaderboards can be messed up. People can take advantage of your systems. This is where most normal programmers fail and suck and keep building systems that keep getting exploited. Systems are more commonly exploited now than ever before in history because programmers don't know security and they keep messing things up. All right? Again, this is super important. This will be on the test. We are not just a comp sci teacher. We are better than all colleges. Why? Because we harp on security. We come from security backgrounds. A lot of us have worked at intelligence agencies, government agencies that specialize on security. So I'm going to harp on this again. Pay attention. This is very, very, very important. So let's go ahead and talk about overflows. Integer overflows. We're going to talk about a bunch of overflows throughout the course, but this is going to be your guys' first overflow. An integer overflow occurs when a whole number is too large to be stored in the number of bits available. An unsigned integer, with unsigned integers, a carryout usually indicates an overflow. With signed integers, check if the carry into the sign is different from the carry out of the sign bit. We'll go into that in a little bit here in a second. In the overflow example below, we will be using a signed byte. Remember, this is important because when you are determining your numbers, you have to tell the computer how much storage space you need. Do you need a byte? Do you need a word, a double word? And that is the allocated space. You do not get more, you do not get less. When you ask for that much, that is exactly how much you get. And issues occur when numbers overflow or go over the number that you are allowed for a maximal value. So, in the overflow example below, we will be using a signed byte. The 1 is the carry into the signed byte 0. And 0 is the carry out of the signed byte. Notice the carry into the signed byte is different from the carry out of the signed byte. This means an overflow has occurred. So if we look here, our original sign, this is a signed integer, by the way. So we only have 7 bits to work with. Let's actually just write this out and do the math. All right, So we have 0, 1, 1, 1, 1, 1, 1. This is where the groupings of 4s or into nibbles is really nice for laying things out. So we got 0, 0, 0, and 0, and 0, 1, 1, and 0. These are signed, which means these guys right here should never be filled with any sort of data, except whether they are positive or negative. We don't have any negative numbers here. We only have 2 positive numbers. We have the number 127 and the number 6, okay? When we want to add these numbers together, let me go ahead and erase this arrow. When we want to add these numbers together, we're going to go about it normally. We have a 1 and a 1, so 1. And 1 and 0 is in 1. 1 and 1, we're going to have a carry. We got 3 here, which means we'll have a 1 and carry. We have 2, so we have a 0 and we'll carry. 2, a 0 and a carry. 2, a 0 and a carry. 2, which is a 0 and a carry. But wait a second. If we carry that, we've just completely ruined everything. We've now turned this into a negative number, and now we have the value 123. We've completely just ruined our whole, potentially we've ruined our whole program. Potentially you've added an exploit. Potentially the game might crash. A lot of things could go terribly, terribly wrong. In the view counter case, the views went into the negatives. It was kind of just funny, but you know, that was a funny sense of it. There are way more serious things that could happen when this happens. So you need to be aware of it. This is not a good thing. Actually, I don't know if the view counter went negative. This can also happen for unsigned data, not just normal signed data. So what happens here is you should ignore this carry. So if we ignore this carry and we actually just put a 0 here, we will still get a weird number. We will get the number 1 plus 4, we will get the number 5. Still potentially an exploit or something that's not supposed to happen this way. Alright? Not desired, but it should be protected against this. Alright? Most applications you should program some type of logic in for this. Not all operating systems, because operating systems like Microsoft and Apple, they want to help devs. They want to make sure you aren't introducing exploits in your application. So sometimes operating systems will try to help protect you against this and will have some safeguards in place. But this is not a guarantee. So it's on you for the most part to take care of this. Let's go ahead and take a look at an example of not a signed byte, alright? Let's go ahead and take a look at a normal signed byte. So a signed byte, let's fill it up completely, and let's add it. Let's add 1 to it. So we have 255, and we have 1 being added to it. When we do this, you'll see that everything will now turn into a 0. Let me go ahead and write the rest of these. We're gonna have 1 left over, except again, you do nothing with it. You throw it to the other side of the room because you were dealing with 1 byte of data. You cannot add more data to the end of 1 byte. 1 byte is 1 byte. It's 8 bits. That's it. You don't get any more, you don't get any less. That is literally it. So this goes completely away, and now your new number is 0. So again, your program's all messed up. So these are things you want to be aware of. Alright? Make sure you're using numbers that are of appropriate size, and if you are using numbers of the appropriate size, make sure users can't do anything weird, because users will always find a way to do something weird and mess up your program. Users are the worst thing for you as a programmer, because they will always break something, right? Any questions on that so far? I don't see any questions right now. Again, this is extremely important. You guys need to be aware this is a thing that exists, all right? And it can mess everything up. We don't need to go through the rest of the book because we pretty much covered it all. Pretty much the programmatic way to resolve this is looking for this carry guy right here. If you have a carry at the end, whether if it's a signed integer, it's at the very, very end, or if it is signed, you'll look at this one right here. If you do have a carry, then you should probably stop what you're doing and revert or handle it gracefully. Luckily, processors at the actual CPU level, like Intel and AMD, I'm not too familiar with ARM processors, will give you an indication on whether you have a carry or not. It's literally called the carry carry storage or something. It's literally a piece of storage on your CPU itself that will be filled up when you do have a carry byte. All right, and it will tell you if a carry occurred, so you can check that at the processor level. This is usually like when you're doing assembly, and you will check it to see if you had a carry or not, and that will tell you and indicate to you, you know, if something is happening that shouldn't happen, or maybe you wanted that to happen. Who knows what you're developing and how you're developing, but there are things out there to help you with this. All right. If you're developing in high-level programming languages like Python, JavaScript, so forth, some cases you won't have to worry about this, but this still can happen in those languages, specifically JavaScript. All right. If Snow is here, Snow is one of our staff members. He is a JavaScript, TypeScript legend. He is probably the smartest person in the world when it comes to those languages. He might as well have written them himself. He will tell you all of the ins and outs of that language and when this actually happens when you're programming in those languages, and the oddness and how it handles it and so forth, and how to protect against it. So be aware of it, all right? Be aware of it so that way you can look out for it and program for it. All right, I still see no questions with that, so we're going to go ahead and move on to the next thing, which is float numbers. All right, float numbers, we talked a little bit about how they get stored. The first bit is also the sign bit. Then we have the exponent, and after that is the significand, or basically the everything that's the actual number that you want, right? So a float number is, in math, what we call a real number. So basically a fractional number. Things like pi are going to be all real numbers. In 1985, that is when the IEEE was created. IEEE created, so IEEE 754 is the actual standard for floating points, all right? And it's for representing floating point numbers. Special values like infinity are illegal values indicating an overflow condition, or NaN, not a number. So these are things that you need to be aware of, especially NaN. These are things that you could run across when you're programming. All right. So here's a little picture that shows you for the different sizes of data that you have. So this is, I believe, so this is 16. So this is going to be for your word, your double word, and your quad word, and how it's laid out and how many bits take up each part. IEEE 754 floating point numbers are broken into three parts: a sign bit, an exponent of base 2, and a fraction called significand, also known as a coefficient or mantissa. Floating point operations are commonly used as a performance measurement known as floating point operations per second, or flops. Typically, CPUs have a fast and efficient arithmetic logical unit, aka an ALU, This is the thing I was talking about earlier that does basic addition very, very fast. There's a dedicated unit called an ALU, and you use it all the time when you're doing assembly, and it is very, very fast. It's the fastest thing on your CPU, which allows them to perform simple additions extremely fast and efficiently. Most tasks that happen in an operating system can be run solely on an ALU because it's all addition. But sometimes a user wants to perform a complex computation or play a graphically intense game. This is where floating point units, or FPU, comes into play. It is not uncommon for a CPU to have a slow FPU, aka a floating point unit, something that will do floating point math, or to be missing one altogether, right? Your CPU will either have one that's slow or it will be missing one that's altogether. And I'll show you guys some CPU specs here in a second and how you can tell, you know, if yours has one and what types of ones it has. It's not too important to you guys, but it is something to be aware of, especially if you want to get into machine learning, because some CPUs you can't do machine learning on unless they have one of these special units on them. So how can you quickly and effectively compute floating point numbers on a computer? The utilization of a graphical processing unit, or a GPU, can help solve that. Almost the entire core of a GPU is completely composed of FLUs, floating point units. This ensures that you will have quick compute times on floating point numbers. This is why the typical measurement of how fast a GPU computes sometimes is in flops. All right, how many of you guys want the new 4080? All right, how many of you guys out there want the 4080 right now? Let's go check out the NVIDIA 4080. Beautiful, beautiful card. If we look at the card, that is, oh, expensive boy. If we look on that, you'll see here in their advertising, and you'll see this all the time in all GPU advertisements. Where is it on? Come on. Oh, wow. You're really letting me down right now, NVIDIA. Not now. I don't want your stuff. Come on. Here we go. View full specs. Well, this is a little disappointing, unless I'm totally looking over it. But you'll see typically some benchmarks or something in regards to their floating point computational speeds, right? It doesn't look like they have anything particularly in here, but if you look up flops for the 4080, you'll usually see on benchmarking sites, they will include it somewhere. Where is it on here? Here we go. Teraflops. 48 teraflops is what you're able to do. And this, hey, look at this. You guys should be able to know what these terms are. When they say FP16, half performance, what does this mean? FP16, floating point. 16 means the bits. So when you're using 16 bits and computing floating point values on a GPU using 16 bits, this is the speeds you're going to get. If you're using 32 bits, then this is the speed you're going to get. And then if you're using 64 bits, this is the speed you're going to get. And as you can see, they call words differently. They call it a half, a float, and this is going to be your double float. Or usually in programming, you'll allocate, it's called a double, but everyone calls things a little bit different. All right. Any questions on that? And then for CPUs, like AVX, there's this thing called instruction sets. Now, the instruction sets for your CPUs are important. I think this is the one that I'm thinking about right now, but instruction sets are important and things you need to look out for. If you're getting into machine learning and you're having weird errors that say check your CPU for, and then it has something around it like AVX, or there's a bunch of different other nomenclatures that are used, but if it ever says check your CPU to see if it has this, it usually means that your CPU is missing one of those special units on the chip itself for performing some type of math. So this right here is AVX 512, which is something for your CPU for doing 512-bit math instructions, all right? So this is something that you need to be aware of. So when we talked about earlier 64-bit and 32-bit computers, at any single one time, that's all they're capable of computing. But there are other things and other chips you can get on your CPU that will handle larger numbers, like 512 bits. All right, there are items in every CPU typically for doing stuff like this, so it can handle more. It just takes a lot of time because you have to move it into these special places and then perform the math on it. It's an expensive operation, but it is possible, especially when you're doing machine learning, because machine learning requires lots of floating point numbers and you need lots of room and data for it. So just something to be aware of. This isn't always for machine learning. For video games, this might be a thing that you need also. So just know, if you ever get an error that looks like that, that is why. All right. Any questions on what we went over? That's pretty much the end of what we got here. We have some assignments and stuff that we'll push out to people in the supporter chat tonight, so you can get some practice yourself. But that officially marks the end of basic math. And now we get to hardware next. So that's what Taylor will start us off with. Any other questions, comments, concerns? So again, to review, tomorrow we're going to just have a chill day, kick back. We're not going to be teaching anything new. We're just going to sit, we're going to chat. We can go over things that you guys want to re-go over, have us recover, give more examples, etc., etc. It's totally up to you guys on what you want to cover that day. So it's whatever you guys make of it. If you guys don't want to do much tomorrow, it will be a really short day. If you guys have a lot of things you want to talk about and go over, it might be a longer day, but it's totally up to you guys. Yeah, thanks. It's been awesome having you here. Any other questions? If there is nothing, I see here, I wrote a JavaScript game on converting bases since you mentioned it earlier. Hell yeah. If you polish it up, make it nice. I mean, if it's JavaScript, I don't know if it's like a console JavaScript game or you've paired it with like a nice little web interface. If it's paired with a web interface, we can host it on the Rootkit site for you, and we'll pull in your repo and host it on our GitHub page so you can get some publicity, and that will be super awesome for us to shout out, and you'll get lots of credit for it. Additionally, you'll get the champion role. Champion role on the Discord is for all of our volunteers. So if you volunteer and help in any way, making videos, supporting code bases, making new projects and adding them, just anything to help the nonprofit, you get marked with the champion role, and that lasts for 3 months. And it comes with pretty much the same perks as up to the kilobyte tier, except without the merch. You don't get any merch. you could get merch, depends on how much you do. We have sent merch to champions if they've done like an immense amount of work for us. Any other questions, comments? Keep us updated on your game. I don't know how far you want to take it, but you're definitely free to post it into the showcase chat at any time and show it off to everyone in the Discord. And then again, depending on how far it is, we can definitely help you with some stuff. I wrote it as part of my Discord bot, but I can add it as a website thing. I mean, even better, hey, if you want to go through all the work to make it a part of a Discord bot thing, we'll take that and we'll add that Discord bot to our Discord if it's like polished and like actually like nice and stuff. You'll have to show us. So take some screenshots and stuff and put it in chat or something, or if you're one of the supporters, you can put in a supporter chat and we can talk about it. We're all about showing off the community stuff. Again, like we've hit on before, we're a community nonprofit, so no one owns anything. There are no stock. There's nothing to be gained or made. No one gets paid except for Kote, and he barely gets paid. And so anything that you guys contribute helps literally everyone. We all rise together. Sweet. If that is all that everyone has got, we'll go ahead and call today a day, and we shall see you guys tomorrow. All right, I know the times have been switching around a little bit weird. I think we're going to move forward with 7, because I think everyone likes 7 p.m. All right, if not, we can go to like 6, but as far as I'm tracking, everyone likes 7. All right, we're going to end the stream. If you have any problems with the time or anything like that, just talk about it in the Discord, all right? We'll be there. All right, we'll see you guys on the next one.